Think math.
A full turn is 360 degrees, clean and tidy. Then radians show up, and a full turn becomes 2 pi, which is about 6.28. Why abandon a perfectly good 360 for a number like that? First, where did 360 come from? The old Babylonians counted a year as roughly 360 days, and they worked in base 60. It does divide beautifully since it has so many factors, but it has nothing to do with the circle itself. It is a number people chose, a convention, nothing more. So does a circle carry a ruler of its own? It already holds one length, the radius. So let us measure an angle like this. How long is the arc it cuts off, compared to the radius? We bring in no ruler from outside. We measure the circle with what the circle already has. The angle whose arc is exactly as long as the radius, that angle is 1 radian. It makes no difference whether the radius is 1 or 100. We only look at the ratio of arc to radius, so the value is independent of the size of the circle. That is why a radian carries no unit at all. It is a length divided by a length. Now measure a full turn. The circumference is 2 pi times the radius. Divide that by the radius, and what remains is 2 pi. 3.14 did not jump in from nowhere. The pi that was always inside the circumference has simply come into view. Nothing strange was imported. To sum up, 360 degrees is a convention people agreed on, and a radian is the ruler the circle carries itself. Radians feel awkward only because we met the convention first. And the moment you pick up this ruler, arc lengths and areas become far simpler. A sip of math every day with Think Math.